Hello, today we're going to look at some of the parent functions and their transformations. So this video assumes that you've seen the parent functions at some point before, and maybe in this course we'll introduce some new ones to you that you haven't seen. But all in all, the parent functions and the way their transformations work, you're going to see that they've got a lot in common. Okay, let's start out with our most basic parent function we come up with out there, and that is the linear one. So the linear parent function we studied a long time ago in Algebra 1, and basically it's, the parent function is just y equals x. What is y equal x? What does it look like? Well, it looks just like a line like that, right? And so whatever x is, that's what y is. So when x is 1, y is 1. When x is 4, y is 4, and so forth. So that's the parent function, and then in the transformation form, I went ahead and wrote this like you learned in algebra, where we have y equals mx plus b. Remember, we always described m as the slope and then b as the y-intercept. And so that's what we're going to keep it as right here as we put it into Desmos. But I want you to graph these three things in Desmos if you haven't already. We're going to look at the parent function, which I just showed you, and then we're going to go to x plus 2 and see how that transforms the graph. And then lastly, we're going to be looking at y equals mx plus b, where we make m and b a slider. So let's hop over to Desmos and do that. We've got y equals x right there already graphed, and then we're going to put in x plus 2. Let's go ahead and just call it the f of x again. There it is. And notice this actually, there's a couple ways we can describe this. It looks like it moved left, and then it looks like we could also describe it as moving up. There's not a whole lot of, until we start talking about the other transformations, it's hard to tell. Did this thing shift it left to, or did it shift it up to? But if we think about what's going on, we are taking what the f of x value is right here, and we're adding 2 to it. So we're actually shifting all of those points upward when we say plus 2 at the end there. And then let's do one more and include some sliders. So we're going to have the f of x is equal to mx. Let's go ahead and add a slider for m here. Mx plus b. And it's not going to, let's see if we can make this thing. Let's try a different t of x maybe. See if it allows me to do b as a slider. What is your deal? The b is a function. Try using parentheses. Let's see if we can do that. I think it's going to make it the b function. We don't want to do that. Let's use a different letter besides b. So what it's doing here is it's not letting me do this because I've already got b defined down here. I'll just change that to t, and then it should let me use b up here. There we go. Now we got a slider. Yours probably doesn't have that because you haven't graphed all these points yet unless you just copied what I did earlier here, or if I shared the graph with you. So now we have m and b as a slider. This is the green function right here in the middle. So as I change the b value, I can see that it moves up and down on the graph there. As I change the m value using that slider, you can see that it's changing the slope. So when it's negative, it's going downhill left or right. When it's positive, it's going uphill. So those are our main transformations when we have it in that format. Let's look at a different one here. So instead of the linear parent function, let's take a look now at some quadratic functions. So our basic quadratic function, the parent function there is x squared. And as we start to graph this thing, we notice it looks like this right here. So take note of this. In fact, if you make this on a chart, a couple of things to notice pattern-wise here. I'm going to zoom in on this graph and move it over. When x equals 1, y equals 1. When x is 2, y equals 4. So notice that we went over 1 and then up 3 units. When x is 3, y equals 9. So we go over 1, up 5 units. Here, let me show you I'll draw it out on a chart here. What I'm saying is this. We have an XY chart. When x is 1, y equals 1. When x is 2, y equals 4. When x is 3, y is 9. When x is 4, y is 16. So remember, for each unit of increase on the x value, we're going to the right when we're going on the x-axis there. Y is going up a certain amount of units. So this goes from 1 to 4, so it goes up 3. And then it goes from 4 to 9, so it goes up to 5. And then it goes from 9 to 16, so it goes up to 7. Notice the pattern here. We're going up by odd numbers. So the next one should probably take us up 9 units. Let's look. When x equals 5, y equals 25. And that is indeed 9 more than 16. So just an interesting pattern there. No, we don't use it every time, but when I'm graphing something, when I'm graphing the basic x squared, that's a quick way that I graph it. So graphing out by hand, I'd say go over 1, up 1, then I go over 1 more, up 3. Go over 1 more, up 5. And it's a quick way to graph it that way, and then of course it's symmetrical over the y-axis. That's a nice, easy way to graph the parent function. But we also have transformations going on here, and that's our transformation form. So notice we've got a little bit more going on than just y equals mx plus b here. We've got an a value that's going to do something to it. We've got this minus h, and we've got this plus k. And for the rest of our parent functions, we're going to see this a, h, and k show up again. So it's important to kind of start to look and see what's going on with the graph. So here's my y equals x squared. That's my basic function that we just graphed in Desmos. I now want you to graph this. Y equals x minus 2 squared plus 3. We're going to do this step by step in Desmos. That's picture me. I want to show you Desmos here. So in Desmos, let's look at this. Here's my x squared, and it's already graphed. Let's take it back to the home screen here. And I want to graph that transformation. Let's do this. Let's say g of x is equal to, and let's just do the x minus 2, and I'm going to square that. Now let's make it a different color so we can see what's going on. So that's the one we're talking about right here. Notice it shifted which way? It shifted to the right 2. So shifting it, putting that minus 2 right here, shifted it to the right 2. What if we made it a plus 3? What do you think would happen there? Let's try it out. Plus 3. Well, that shifted it to the left 3. So notice that it shifts it kind of, to me, it shifts it the opposite way I would originally think it would. So this goes the opposite direction, left or right. So plus 3 means it goes to the left 3. Minus 3 would mean it goes to the right 3. So I'm going to turn this back into what I told you to graph. I said x minus 2 quantity squared. And then I said to add 3 on the outside. So when we add 3 on the outside, notice that shifted it up 3. So that kind of shifts it the way I think it should shift it. Shifted it up 3. What if I made it a minus 3? Well, minus 3 shifts it down 3. So we can already see some patterns here that if it's paired with the x, it goes the opposite direction that we might think it would. And if it's on the outside, not grouped in parentheses there, it's going to shift it up or down. Now, take a look at what we had planned for the transformation version on this, and we're going to add sliders to it again. We want this to be, I'll show you on this screen. Whoops, that camera's turned off. Let's turn it back on. We've got y equals a, and then x minus h quantity squared plus k. So that's what I want you to type into Desmos now. So let's type it in as the g of x again. And this time we've got a x minus h quantity squared, and then plus k. And this one's upset again at me. It's because I've got an a right here. Let's change that to a z. And then that will make it a little bit happier. Let's see what else is going on. These things really mess me up, don't they? Let's just get rid of these. We'll put them in a second together. There we go. Now we got some sliders coming in. Add them all as sliders. So now I'm going to do one more thing. Remember, if you hold down the left mouse key there, it allows me to change the color. I'm going to make this one purple, so that way you can kind of see the difference between them. Or you know what, you could just turn these off, and then we can see what happens when we change these values. Now we just talked about in the last example that -2 right here, that's the same thing as our minus h. So we can see as h is positive and we move it this way, it's going to shift it to the right. Now remember, when h is positive, like right now it's +6, when you put it into this equation right here, it becomes x minus a +6. So that minus sign right there is what we typically look at. So -6 means shift it to the right 6. If we made h negative, that's what we just looked at and said, what if it's a -2? Then remember, -2 going in, I can't, there we go, landed on the -2. -2 going in for h makes it go x minus a -2, which is the same thing as x plus 2. So in the equation, we would see it as x plus 2 quantity square, which means shift it to the left 2. So that's our h value there. And then remember k on the outside here, that was the same thing as +3 in the last example. And this is going to shift it up and down. So when k is negative, it shifts it below that vertex below the x-axis. And when it's positive, it's up above. And that leaves us with a here. So what does a do? So as I make a larger, notice this thing gets skinnier, I guess you could say. And so the question is this a vertical stretch or is it a horizontal compression? And so what do you think it is? So if I've got this in Edpuzzle, hopefully I remember to put a question in here. If not, I want you to think about it. Do you think it's a vertical stretch or do you think it's a horizontal compression? Take a look at this graph right here. Now this is just simply y equals ax squared. But the reason why I do this is I just want you to focus on the a here. As I drag this a, it's going to, once again, do that vertical stretch. So that's the answer to the question. It's actually a vertical stretch, but some people don't believe me. They say, you know, it looks like this parabola is closing in like it's being compressed horizontally. What I've done is I've got this parabola and some points on it. And I'm going to change the value of a, that coefficient to the ax squared term there. As I make a larger, notice what's happening to those points that have kind of stuck onto the parabola. They're not moving left or right. They're not moving inward. They're actually moving upward to show you that our y values are increasing here as I make that happen. And so it's actually a vertical stretch. Now, as a becomes smaller and smaller, notice that it's headed towards the x-axis. And so we see that, you know, it looks like it's growing wider, but actually it's being compressed there, a vertical compression. So that a term either stretches it or it compresses it, but its keyword is vertically, up and down there, okay? Now, what happens when a is negative? Well, I can go ahead and make this negative here. Notice that it flips it. And if I zoom out, you can see that as it gets closer and closer to negative infinity, that thing starts to stretch vertically again, but now in the negative direction. That parabola is opening up downwards. Going back to our other graph here, we're going to see that now, you know, all this comes together. If I slide this, I can make it open up downwards. I can make it open up upwards. I can shift it left and right by changing my h value here. And I can shift it up and down by changing the k value. These things are going to, the a, h, and k, they're going to show up in our other functions. So I'm just going to leave those sliders in there. I'm going to turn off this. Our next function we're going to look at is going to be the absolute value function. So our absolute value function looks like this right here. And so we write it out like this, y equals the absolute value of x. And then our transformation form is going to be, notice that a there again, x minus h, the h is there again, and then the k right here. Notice once again, just like on our last one, if we look at our quadratic one, it's almost the same setup. The only difference is we don't have it wrapped in parentheses and squared, but h is still paired with the x, k is on the outside, and a is in front. And essentially, we're going to see that it pretty much does the same thing to them. So let's hop over to Desmos. And I deleted it earlier. Let me go ahead and add that back in here. So I'm just going to add it right here. We'll call it the f of x again. It's fine. It shouldn't hurt anything. So the f of x. And whenever you want to type in absolute value, there's a couple ways. One, you've got a keyboard shortcut here. Or you can just type in ABS for absolute value. Well, I thought you could. Let's see if that does it. There we go. The absolute value of x like that. Although I don't like the way that looks. I'd rather go to the keyboard, and right there is our absolute value symbols. We can put x in there because that makes it a little bit cleaner look, I think. So there's your absolute value of x. So it looks like that v right there. And if we add to that the minus h in here, and on the outside a plus k, and in the front we're going to have an a. Now these are all stretched out and moved all over the place because we've already got values for a, h, and k. If we make the value of a 1 and then h 0, come on, get there. Here, it's hard because I'm using a trackpad here. Let's see if we just type in 0, and then k's value is 0 as well. We get our parent function. That's the same thing as the absolute value of x, but now as we start to slide these around, we notice that if I make h plus 3, notice it shifts it to the right 3, or in this case 2.9. Let's make it 3. The reason why this is written out, when you put 3 in for h, you end up with x minus 3. So it's going to shift it to the right 3. Anything I put in for k is going to shift it up or down that value. And of course, a, once again, is going to give me a vertical stretch or vertical compression. I want you to take a look at this transformation right here and see if you can make a prediction on how the transformation is going to go. So the first thing, what's this minus going to do? Well, it's going to flip it. What's the plus 2 going to do? In this case, the plus 2 is on the outside, so it's going to be a vertical shift up 2. And then what's that minus 3 in there going to do? Remember, intuitively, I want to say it's going to shift to the left 3, but what it's really doing here is it's moving the opposite direction of what I feel like. It's going to go to the right 3. So it's a rightward horizontal shift 3. And so you say, wait a minute, if we make h right in here positive 3, how does it go to the right 3? Remember this, when we put 3 in for h, you end up with x, put a positive 3 in for h, you end up with x minus 3 when we substitute it in for h here because of the minus already there. If h were, say, negative 5, when you put it into this equation, it would become x minus a negative 5, which is the same thing as x plus 5. And so that when you see this in the equation, you're actually shifting it to the left 5 because your h value there is actually negative 5. So you can put that in Desmos if you want and check it. Right now, I'm going to move on to the next one, which is going to be the cubic function. So here's our cubic function. The parent function is y equals x cubed. Let's take a look and see what that looks like in Desmos here. So in Desmos, I'm going to just type out y equals x cubed. And there's our parent function. Notice the transformation form of this thing. It's going to be the exact same setup as we had before. You've got an a out front, then you have an h paired with the x, and then a k on the outside there. They're going to follow that same pattern. The a can flip it. The h is going to shift it left or right in the opposite direction we think. And then the k is going to shift it upwards and downwards. So for instance, go ahead and take a guess on this one. What are its transformations? Well, what's the a value? The a value here is 1. So it has no vertical stretch or compression compared to the parent function. It's also not going to flip it. The plus 1, remember it's paired with the x, so it's going to shift it to the left 1. So this is going to be left 1. And then the minus 4 is going to shift it downward 4. So this is going to be down 4. All right. Put this into Desmos, and you've already got sliders already created for it. So switch over to Desmos. And I'm just going to put it right in with this one. I'm going to put the a right here. And then grouped with this, we're going to have minus h. And then on the outside, arrowing over, I can get to the outside and put plus k. And so once again, they already have some values here for a, h, and k. Notice the h shifts it left or right, and the k shifts it upwards and downwards. Now, what does flipping it look like? Well, notice that as h is positive, not h, as a is positive, if I make it, the larger the number, it's going to start to stretch it vertically like this, just like we've seen with the parabola. But as I get to 0, not 0, but 0 just makes it a line, right? If I make it negative, notice it did flip it here. And until we get used to seeing cubic functions over and over again, you might not notice that it did flip. Take a look at what it looks like. I've drawn it out here. When a is positive, it looks like this. And when it's negative and it's flipped, it looks like this. So if a is positive, it's starting from negative infinity and working its way out to positive infinity like this. So the graph has that shape to it. And when it's negative, we're flipping that. So instead, it's coming from very large y values and it's exiting the graph going towards very large negative numbers. Okay? So keep that in mind. These shapes, we want to start to recognize these so we can say, hey, that looks like a cubic function when it has that squiggle to it. And that a being positive or negative will start to affect our graph as far as like what happens when x approaches positive infinity or what happens when x is going towards negative infinity. All right, let's look at another parent function here, and this one's going to be the square root function. Let me move these off. So our square root function looks like this. We've got y equals the square root of x. Let's take a look. If you're not familiar with it, let's move it to Desmos here and type it in. I've actually got it typed in right here for the t of x. That's what it looks like. Notice its domain starts at 0 and goes towards positive infinity. And then if you look back at our transformation form here, we've got the a, the h, and the k here again. The same things happen with it. The a will stretch it vertically or flip it if it goes negative. The h is going to shift it left or right in the opposite value of whatever we've got written in the equation. And then the k is going to move it upwards and downwards. So here's the function we just graphed, y equals square root of x. What transformation is going on here? Well, we've got a -1 for our a value, so a equals -1. That means it's going to flip. It's not going to be stretched vertically, but it will flip it. And then the -3 is paired with the x, so that's going to move it to the right, 3. And then lastly, our k value is what here? Well, our k value is 0. We're adding nothing to it, so it's not going to be shifting upwards or downwards. So look at Desmos, and I'm going to put right in here a negative out front and watch it flip. There you go, it flipped. And then paired with the x, I'm going to put that -3 there and watch it shift to the right 3. -3. Boom, it shifted to the right 3. So that's the transformation I just showed you. Let's go ahead and put in our variables here. So if I change this -1 to an a, I'm going to change the 3 to an h, and on the outside I'm going to put a k value, so plus k. And now changing these sliders, we can see the transformations. Notice that's our vertical stretch, and as a becomes positive, it's going to look more like the parent function. And then h is going to shift it left and right, and k value is going to shift it up and down. All right. So let's look now at another parent function here. And that's going to be our rational functions. So rational functions, and rational, that word rational, just so it helps me remember if I know the root words here, that root word ratio. When we write out ratios, like if we say there are 3 boys to 2 girls in the room or something like that, we can write it out as 3 to 2. We can write it out as 3 to 2 like this with a colon, or we can write it out as a fraction. And so this is a ratio or a fraction there, and that's where we're getting that word there, rational. So when we say rational functions, we're talking about functions that are fractions. You know, we got that fraction mixed in there. So the parent function is 1 over x. And let's just take a look and see what that looks like in Desmos. So we've got 1 over x looks like this. Let's turn off that square root function there. And so we're going to have a whole chapter on just rational functions, and we're going to start graphing these by hand. And don't feel intimidated. It seems like a lot of times students are like, oh my goodness, I can't graph that by hand. You can. There are certain things I look for and I'll tell you what to expect when you go to graph these things. But I want you to get used to seeing this parent function here so you can apply those transformations and it becomes super easy to graph. So that's what it looks like. Notice, let's go ahead and put in the transformation form. If I put an A out front, and then with the x, so in the denominator here, I'm going to put x minus h. And that's, once again, it's going to shift it left or right like it did on the other ones. And then a plus k on the outside, that's going to shift it up and down. So notice that k right there, it shifts it up and down. It may not look like it. It kind of messes with my eyes when I see it. But that's what's going on. The thing is shifting up and down. You can zoom out if you want to, and maybe that's a little bit easier to see it shift up and down. And then the h shifts it left and right. That's just dragging that slider. And the cool thing about these sliders is if you're trying to just watch it shift, you can hit play, that play button right there. And I'm not even touching it now, and it's shifting it on its own. And so that'll, you can see what's going on with that. Some students like to get crazy and hit it on two of them, and you can see it move around. Reminds me of the DVD screensaver thing where it's moving around. So that is the h and the k, left and right, up and down like we're used to. And then we've got this one more right here, the a value, and it's going to do the same thing. If I move and make this a value super positive, it's actually going to do that vertical stretch or the compression again. And notice what it looks like when a is positive. When I make a negative, notice it flipped again. See the difference between the two? That's a is negative. Boom, there's a is positive. So I always call these two things the curvy corners. Pay attention to where the curvy corners are. Right now, when a is positive, it's in like the top right and bottom left. When a is negative, notice they switch. Now there's a curvy corner in the top left and bottom right. And so if we look at it like this, if we go back to our paper here, when a is positive, I guess I should make a note here that we're talking about the a value. When a is positive, it looks like this curvy corner right here. If you think about them like quadrants, they don't necessarily have to be the quadrant. You think of it as quadrant 1 and quadrant 3 right here where they are. And then when it's negative, they flip. So this flips to up here, and then this top right flips to the bottom right. Now notice there are some vertical and horizontal asymptotes on these, and we're going to learn where to graph those when we start talking about rational functions. Okay? So if we look at, I want to look at this one right here before we leave, and I want you to identify what transformations are going on. So looking at this one right here, this is paired with the x. So this moves rightward. Remember, it's opposite of whatever symbol you see in there, so right 2. And then this one is on the outside, so it's going to move up 1. Notice our a value here is positive 1, so there's no shift there. And other than that, we should see that when we go to graph it, okay? So that kind of recaps all the different transformations you can have. So I want you to take a look at that, try out the practice problems. If you have any questions, let me know. And as we go through the chapters, we're going to look at each one of these functions and start to learn how to graph them. But these transformations are going to be essential to understanding how to graph them easily. Okay? Thanks for watching. And once again, let me know if you have any questions.